Alright guys, so in this video we're going to go over, I'll briefly go over this problem right here where he kind of jitters there. Now that's caused by RVO avoidance, and I believe it's caused by RVO avoidance, probably not exclusively, but I do believe that plays a factor in it. And under the crowd manager in your project settings, when you're using the Detour crowd AI controller, these are the settings that control that. So I don't know a lot about tweaking this. I'm not really that familiar with it, so I'm not going to go into it, obviously, but you might be able to find a video on the crowd manager or something floating around. If not, then you can go to your AI controller and you can reclassify this as a regular AI controller, and then you can just try using the RVO avoidance on the character movement component. So let's just type in avoidance. So right here you'll see we have this RVO avoidance, and this is the avoidance consideration radius, and that's the weight. So that's all the control you have over it whenever you're using it from the character movement component. And in fact, you can actually have both the Detour Crowd AI controller RVO avoidance and this enabled, but I don't think there's actually really a point in it because it's already being used by the Detour Crowd AI controller, and it's kind of integrating it into the pathfinding. And so if you use this one too, it may seem better. I've seen some comparisons of using both versus one, but I think you're just doubling the performance hit of it for no good reason. That's just my opinion. Anyway, I mean, if you type in ROT, you'll see the rotation rate here. It's 500. That is pretty high. And so if we turn that down, that'll probably smooth that jittering out quite a bit. Just be careful not to turn it down too far, or your character won't be in sync with the way he moves. So you see that time it was a little bit better. It's not jittering now, so the rotation rate does have an effect on that. If the rotation rate is too high, it can cause jittering with the AI. But anyway, let's go ahead and dive into the environmental query system. So we'll go ahead and start setting that up. And so under our smart objects, I'm just going to place it in this folder. And my organization for this series isn't really great. Follow my organization skills in this project at your own risk. But anyway, we just want to create an environmental query, and that's going to be under the artificial intelligence category, environmental query. And so we're just going to say EQS query smart object actor. So we're querying an actor of type smart object. And so in order to do that, we actually need to be able to query a parent class of all smart objects. So that's where inheritance comes in. So actually I already started this, but I kind of made a lot of mistakes, and so I started over again. This would actually be the bench right here, but let me just update these redirectors. So that actually was the bench, but we're going to rename it to smart. Let's name it to SO master, smart object master. And then we're going to create a child blueprint of it, and we're going to call this bench. And so we are going to replace this one in the world with this one that's selected. So we're going to right click on it. If I can get it to right click, sometimes it won't do it. So you might have to zoom in and right click on that little decal, and then go to replace selected actors with BPSO bench. And so now it's been replaced. So we're going to open up both of these first off, because we're going to clear these out on here so that These won't be loaded into memory automatically whenever the game starts. And so we're going to manually set these on the other one. And I'm going to clear this one out too. So I'm going to go to this one. And we're going to leave this channel the way it is right here. You could also make your own collision preset for smart objects if you want, or you can modify the ones that are already there. If you want to modify the ones that are already there, you can go to collision presets, and you can just double click on one of these and you can modify them, change their object type. I'm not going to go too in depth on that because that's not what this is about. But anyway, so we've cleared out that static mesh and we're going to set this one with the same one. And so now basically everything's the same. So the main point of that is that if you want different types of smart objects, then you're going to want a master smart object. And later in the series, I'll show you how to do a general smart object that I used in my project. And I guess I don't have it open right now, but I'll go ahead and open it and I'll go over that with you guys just so that you understand what I'm talking about as far as a general smart object. Because I did explore this a little bit and they seem a little static and not very flexible. But if you do things just right, then you can make them fairly flexible. So right here I have a general smart object definition, and I'm using the same one for like 5 different things over here. And basically I'm coming in here and I can change the state tree if I need to, or the smart object definition itself, but I can change the state tree that's assigned to that smart object definition to a different state tree. You see, and I'm actually doing that in one of these cases over here. So that kind of allows a little bit of flexibility. And how am I doing that? I'll go ahead and go over that with you since I'm already in here. So actually, all you have to do, and I guess I'll remove this, but all you actually have to do, let's see, is you see right here where the state tree is, press this little button here and promote it to a parameter. That's all you have to do. But yeah, okay, that caused it to, undoing it caused it to crash. That's all right. But anyway, you get the point. So anyway, moving on. And it looks like I restarted it. Sorry about that. But yeah, so I'm using a tag. You know, I have these different things so that I can loop it or do montages. But anyway, so moving on, we're going to go ahead and set up our EQS for this now. So we can actually close out both of those since we've already taken care of that. And under the smart objects, you'll see the EQS. I'm actually going to drag this master out into the smart objects folder right here. Now, anytime you move something, right click on content or right click on the folder you're in and do update redirector references. I always do it on content because I might accidentally miss something if I don't. And then you just press that button on the left whenever it pops up. So what that does is it fixes redirectors. If you don't and your game crashes for whatever reason, why there's redirectors floating around in here, then it could break them and it'll cause problems. So anyway, opening up the EQS, you'll notice that under the generators, we do have a smart objects. The problem with this is it seems to be, its purpose seems to be that it'll actually just return the location of a smart object slot. That's basically what I'm getting from it. So it actually just returns the location of a smart object slot. We don't want a smart object slot location. We want to claim a smart object. So the only way that I know of that we can do this is by actor. So if we have a reference to the smart object actor, then we can still claim a slot on it from that reference. And so we're going to do an actor of class here, and we're going to set the search radius to something like 1500 or 2000. It's up to you, but if you come over here and you go to your top right here, you can press your middle mouse button and drag out, and that'll give you an idea as to how far 1500 is. So that's a pretty good distance, as you can see. 1500 is. So 2500, as you can see, would probably, it would look to be about double that. Yeah. So anyway, that's how you can determine how far out you probably want it. And you can actually create a query parameter right here, and you can pass in that search radius float value externally. Now, as far as I know, you can only do this with float values. Anything that has a float value, you can do a data binding to it as a query parameter, and then you can pass that in. But I only know how to do that with parameters. I mean, float parameters. So anyway, the search center is the querier. So the querier is the one that's the actor that we're doing this on or for. So the searched actor class, that's going to be our BPSO master. And so we're looking for anything of type smart object master. Yep. And so now we can set up, let's say, distance. We can filter by distance. So if we click this, you'll see we can set a distance range. I'm going to do inverse linear to inverse that. Otherwise, if you, by default, with linear, you're searching for things outside of this range, basically. Well, this is the scoring. So actually, with the linear, the further away it is, the higher the score it gives it. And so if you do inverse linear, then the closer it is, the higher the score. And you'll see it right here. It says prefers lesser distance. And so we'll do something like, let's just say 150, and our max will be 2000. Well, it'll be 1500. And really, we don't need a max, so let's just set a minimum. So our minimum will be 150 because our radius is already clipping everything else out beyond 1500. So there's no point in doing a range-based filter and score system. And in actuality, I'm not sure we actually even need to filter. Yeah, I mean, I guess we could only do the scoring part of it. So it's up to you. So we'll do a dot product too. And what this will do is it'll allow us to, and I'll show you how to test this too without starting the game. So what the dot product will do is it's going to allow us to test to see how that point is oriented, or that smart object actor is oriented in relation to the actor that we're querying for. So for line A, this is where it starts at. We're going to do a 2-point mode from one location to another. And so we're starting at the querier and we want to go to the item. And so you can actually create your own environmental query context that stores a specific actor, and it'll show up in here too, but I'm not going to go over that in this one. But for this, we just need the querier and the item. So the item is actually the point that shows up in the query. And so in order to make this clear, we're going to go ahead and create that actor I was telling you about. So right click and go to Blueprint class and just type in EQS, and you should see EQS testing pawn. And we're just going to call this EQS testing. And so it looks like I don't know what's up with that. It's weird. Okay, man, dude, this has been happening a lot. It's so annoying. This bug has been in here since Unreal Engine 5 was released. They need to fix it. Basically, my screen is frozen, and I have to reload the map or restart the project in order to unfreeze it. It's some kind of rendering bug. I don't know. It's really weird, but it's hyper annoying. So anyway, under Smart Objects, EQS Testing Pawn will drag this out. And it should already be pulling them up, but it's not. We're supposed to be seeing the, oh, right, okay. I'm missing this right here. So go into Details, EQS Query Template, and we want to choose that one that we just created. And so now you'll see that there's a little blue node right here saying that it's being filtered out. That's not included in the filter. And so, and that's because we haven't finished this dot product right here. So we want to, whenever we do the 2.1, we're doing a line, or we're doing the dot product in relation from this actor right here to this item right here. This is the querier, this is the item. And so that's why we're doing that. And then rotation. The rotation of the querier is what we're interested in. And we want this to be 2D because we don't need it to be 3D. It'll be more performance friendly if we do 2D. And so we don't necessarily need to filter those. So we could actually just do score only. And we'll do, let's see. Okay, so right now that seems to work. We need to duplicate this in order to fully test it. And so if we select this other one right here, if I can get it to select, and you'll see it hasn't updated yet, but as soon as you move it, it'll update. So you'll see this one actually has a low score, but if I rotate it, that score goes up and the other scores go down because as you can see, the character is pointing this way. So that allows us to make sure that that the ones that are more closely oriented with the character will be scored higher, so that he goes to one that makes sense. Because you would expect him to walk forward towards a bench rather than turning around and walking to the one behind him. So that's just, you don't have to include that, but if you want to include it and then just disable it, you can just uncheck that and it'll disable it. That's all I'm going to do for this one though. If you want to know more about environmental query systems, then you can go watch dedicated videos on that. So anyway, that's an environmental query for a smart object. So we could actually move the state tree over here, but I'm seeing some kind of weird bug. Whenever I move the state tree over here and I do a state tree AI and I convert this one to a state tree AI, then what happens is it won't actually load up unless I specifically do a start logic. Yeah, let's see, state. So it won't actually start for some reason, even though it's set to start, unless I do a start logic off of it. So, I mean, you could move it over here if you want. You'll still have access to the third person because this actually gives you access to that. And in fact, I guess we can go ahead and do that. So if there's any problems, you can always switch back. It shouldn't be a problem. But you have to set this to state tree AI component. And then over here, we're going to remove it off of this one, compile it and save it. And then over here, it should show up. If it doesn't show up, that's because you forgot to set the state tree AI component from state tree component to state tree AI component. It needs to be state tree AI component, or it will not show up in the state tree AI component. So with that out of the way, we'll see if that works. If it causes any problems, we can go back and fix it. Now that doesn't require us to change this use smart object task to an AI controller, but it probably actually makes more sense now that we have a reference to it. So we'll go ahead and change that. So you'll see right now we're getting the AI controller from the actor. We don't actually need to do that. We can say AI controller, and we can change this to an AI controller type. Now we can just plug that directly into there and it'll work. I'm going to toggle those off because I don't need those anymore. So, let's see. Let's go ahead and open up our Find Smart Object. We're actually probably going to have to copy this over. Now, I did have some problems with this when I set it up in mine, and I think it's bug related. So what I ended up having to do is whenever I set mine up on the EQS one, for some reason, this claim handle never properly makes it over to this use smart object. Even though that it's bound to it, it's not making it over for some reason, and I don't know why. Now, in my project, the same thing happened. And so what I ended up having to do is I ended up having to store this claim handle reference on my AI controller. And then I had to, whenever I used it, whenever I called the use smart object, I had to call this off of my AI controller. So we can actually do that as well. So what we'll do, we'll just leave this like it is. We won't change it to an AIC NPC. What we'll do instead is we'll end up binding it from the AI controller since we have access to this stuff in here. And we'll change this one to AIC NPC. And then on the AI NPC, let's see, I'm going to copy this and I'm going to paste it in here, and then I'm going to create a variable. So this is where we will be storing it, the claim handle. And this will give us a workaround. And now we'll be able to actually bind to the claim handle on our AI controller. So first off, let's just go ahead and make sure this still works. So we'll go to the debugger. Okay, so you'll see the debugger, it's still showing that it's working, which is good. We wanted to make sure that it still works. If it doesn't work for you, let me know. Maybe just revert back and store that variable on the actual actor instead. That's my only solution for now for that problem. I do believe it's a bug, but let's just go ahead and create that task. So we're going to create a new state tree task, and we'll call it query smart object. And so we'll do an enter state, and we need an AI controller, and we'll do this one as an AI controller. And now what I did on mine, and let me actually just close this because people might start blowing me up. I did a stop movement on mine, And now it's doing it on my phone, so let me silence my phone. So yeah, so I did that. You don't have to do that. That's just something I did for mine. I don't even remember why I did it, but you might find that it's important for whatever reason. So, like if you're chasing an actor right here, then and you interrupt that, then it might be that he continues chasing the actor. I think that was the reason why I did it on mine, just as a fail safe. But anyway, we're gonna do an EQS run EQS query, and we're going to run this specific one right here. We want the single best one, but you can choose the random best 5 or 25%, or you can do all matching. You can also set up a wrapper class. I'm not sure what the purpose of that would be though. You can also do a set named param, and that's what I was telling you about the floating point values, but you have to pass in the name that it assigns to it. So for example, if I come in here and let's say I want to bind to this search radius to a query parameter, you'll see that this is the name. And so this would be the name that I would actually have to give it. And then I would have to set the value of it right here. And that's how that would work. So I'm not going to do that in this one. I don't really feel it's necessary, but I wanted to show you how you could do that. So that's how you would do it. So what we do need to do though is we need to bind event to onQuery finished. So when the query finishes, it'll return a value. So off this event thing right here, we want to do an event dispatcher and create event. And I like to do it this way because it's wireless and create a matching event. And then we'll just say claim smart object. So what we're going to do off of here is this is going to return the status of our query if it failed for whatever reason or whatever. So we're going to do a switch off of this. And this will allow us to fail this state if the query itself failed. And that's the reason why, because we only want it to try to do this if it's successful. So off of the query instance, we can say get query results as actors. So this will return all the actors that pulled up. And since we're doing the single best item, there should only ever be one that's returned here, but it will return it in an array. Just know that that doesn't mean oh, I don't know. I'm saying break branch. So we want to do a branch off of here. Sorry, I get distracted easily in case you haven't noticed. So we're going to do a finish task here, and we want it to be a failure. If it failed, was aborted, owner was lost, or if it's missing parameters that are required, then we want to fail it. And if this fails right here to find or to get the results as actors, then we also want to fail it. Now, this is actually going to return a copy. I don't think that's going to be a problem. That wasn't a problem for me, but it seems like you can only get a copy of the actor and not an actual reference to it. If you do a for each loop though, it'll return an actual reference to it. So I'm thinking that this copy right here, in terms of actors, it's not actually copying the actor. I think it's probably just passing a pointer. I don't know for sure, but anyway, so off of this find smart objects, what we're going to do is everything after the find smart objects right here, we're just going to copy all of that, and we're going to paste that into here. So actually, we don't need that part because I already set that up. And we're just going to, let's see. Oh, right. Okay. So what we need to do is we need to do we need to scroll down here until you find smart objects. Let's see, because I don't remember the exact name of it. Okay, so find smart objects in actor. This does not require the smart object subsystem, and so that's why I manually searched for it. So this will go into this random node. And actually, I guess we didn't need to delete that. This has a return value, so we want to do a branch off of this, just like we did before. We want to try to catch, if something fails for whatever reason, we want to know what it was. Or we want the state to fail. So we're going to, you see this filter here, we're going to promote this to a variable so we can set it from the state tree itself. This user actor, same as the one over here, it requires some kind of actor. So we're going to replace that one with the AI controller. And we're going to we're going to hook this one up to it too. And then we're going to, well, the thing is this is the part where we have that problem. But yeah, let's promote that to a variable. And I'm going to do a set by ref. I'm hoping that'll work. And so if I set it by reference, then what we can do is we can make this an input. And that'll be a required one. Also, we need to make this context. So this will be an input, and so it won't compile unless we bind this to that variable. Kind of saves us from ourselves. We don't actually need this to be hooked up, but what you can do is you can do a should finish task and make this a Boolean and expose it, expose the filter as well. And if that's true, then we'll fire a finish task. That allows you to use it however you want in the state tree. So you can use it like I'm doing here, or you can use it as a standalone. It gives you that freedom, and that's the reason why I did that. So I do that on my own as well, so that I can determine if it should finish the task or not. Because if it finishes the task and you have multiple tasks here, then it probably won't execute the other task, depending on your order of operation, obviously. But that should pretty much be it. So we're gonna, oh wait, no. Let's go to class settings, and I believe this was custom bar smart objects bar utility. And we'll call this query smart object. And so this will look for the closest smart object to the player, as demonstrated here. The closest one and the one that is directly in front of them, more than likely, not necessarily. If, say, he's over here, then it may be the case that it selects this one. It actually looks like I might have, oh, my search radius? I thought I set that to 1500. Oh, okay. Anyway, so you'll see that just because that one's not directly in front of him doesn't mean he won't choose it. He'll choose this one because it has a higher score than that one. So in some situations, just because he's not facing it does not mean that he won't choose it. So I wanted to point that out. So we bound this one to that variable on this one, the claim handle, and we're going to bind this one to it as well. And so actually we could probably, okay, that one's already an input, so it forces us to bind. Okay. So we're going to switch over to query, and we're going to select this right here, and we're going to bind it to that claim handle. And we don't want that to finish the task, so we'll leave that disabled. But if we did, we could check that, but then the use smart object wouldn't be executed. Most likely. Can't be 100% sure on that. So they'll probably fix that later in the future, I imagine, so that if tasks are stacked, then they won't exit, they won't finish, and they won't transition until all of them have executed. But currently, if you fire a finished task and there's multiple, then it's going to transition regardless. So that's just something you have to keep in mind. I'm hoping I got everything right. We will see. So remember that bug I told you about? So I can't be too sure that hasn't affected this. So it doesn't look like they're moving, but you'll see that they are looking for smart objects. For some reason, it's not actually doing anything. If we break on exit, the thing is though, is that these breakpoints inside of here, they don't always work. So they're supposed to pause it, in case you didn't know, but they don't always pause it. Okay, it paused it. Okay, let's see. So I think it's exiting it. Oh no, it entered it. Okay, yeah. So at least I know that works. Let's see if it does it on, if it does exit it. It does not. Okay. At least it doesn't appear to be, but you see this is flashing right here. I don't know if that's important. I don't think it is, but it seems like it's stuck. So what we need to do is we need to let's see. This might not be working. Let me set a breakpoint right here. And we'll fire this and see. So you'll see we do have a claim handle here. And it did give it a user ID. This was the same problem I had before. I thought this would fix it. Let's toggle breakpoint on this. Okay, so it's passing the user handle, but the smart object handle is not there. So we can go to Blueprint Debugger on this, and we can search for claim handle. If you're using an older version, this will cause your computer to seriously lag. Just giving you a heads up. So I'm pressing this arrow here, and it's not expanding, which probably means that it's a null variable. It's never been set. Let me just confirm that first, though. Okay, that's not the case. It's a bug. Okay. But yeah, the smart object ID and that slot handle, it's not being properly set. Okay. So that kind of complicates things. I don't know if setting it directly will actually fix it. We might have to use a blueprint interface. I used a blueprint interface on mine. I thought maybe that would work, but Let's see. So you'll see that one fires first for some reason, and then this one fires, and then that other one will fire. I don't know if that's a bug or what. I feel like it shouldn't be doing that. So the smart object handle is 5953, and right here you'll see it says 5953, but this is for AI controller NPC C1. So over here we'll go to, let's do the debugger again. NPC C1, this one right here, and you'll see it's empty. It has no smart object handle ID. So it wasn't properly set using this method. So we're going to have to create a blueprint interface. That's how I had to do it in mine, guys. I don't know what's up with that. I hope they fix that here soon, but let's just do a BPI NPC or AIC NPC. And then we'll go to class settings under interfaces right here. We'll add the BPI NPC. And let's just go ahead and press this browse button. It'll open it up. I'm going to call this set claim handle. And I think it's a little ridiculous that I have to create setters and getters on a blueprint interface just to communicate, but until they fix those bugs, that's what we're going to have to do. And get claim handle. So the get claim handle is going to return a claim handle. And if you're confused, you can move your cursor over this smart object claim handle type. So smart object claim handle and claim handle. And then on this one, this will take a claim handle, and it should automatically set that one for you this time. And then we'll save and compile, and then over here, okay, you have to compile it, apply the setter, and the getter. And so now, oh wait, that's not going to help. So we actually need to use it. So off of this AI controller in here, we're going to do a set claim handle message, and we're just going to pass that in like this. And so now we can actually remove that because we don't need that anymore. And we're going to compile and save it. And I'm hoping this is all we have to do, but if you want to be safe, you can actually get it here. So what we could just go ahead and do is we could just go ahead and preemptively do this so that we don't have to worry about any problems. So we'll go ahead and remove that, and we'll just save that. And now it should work, I hope. So it looks like it's still not doing anything. So let's see here. It's not even running. So this seems to be a bug. Something to do with maybe converting these. Oh wait, it didn't compile. So we need to recompile. If yours shows a little red thing up here, just recompile it and save it, and then run it again, and it should start running. And let's see, hopefully, we're still not receiving an ID. Okay. Okay, so that might have something to do with it. So let's do it like this. And let's see if this fires, then we'll know that that this was set properly. Okay, and it fired that time. And we're still not getting a claim ID. Okay, I'll be right back. All right, so this seems to be a timing thing, and this is really weird, but if you don't check to make sure that your claim handle is valid beforehand, before trying to use it, that seems to break it for some reason. I don't think this lock AI logic thing was a factor in that. I did disable it. But what you need to do is you just need to drag off of this and do an is valid check, and then just do a branch off of that. And then just copy and paste this right here and plug that into there before. So that's basically the rundown on that. And I'm just going to move this over here. And you can actually temporarily store that and then plug it in over here, or just rewire it like this, like I'm going to do. Totally up to you. But that's basically all I had to do to fix that. So I'm going to disable that and leave everything else like it was. And so now it should be working for you. Let me just disable that. And there you go. And you'll see the NPC IDs right there on those lines. So there you go. That's that part out of the way. Thank God. Oh my gosh, I had to do this like 3 times in a row, guys. it was bad. All right, so finally I was able to get you guys moved over to the to where your state tree is on the AI component controller. I didn't really have to do mine quite like that. So, or maybe I did and I just didn't realize I did it. Anyway, little bit involved process there. It can be frustrating at times. We got it working though, and now everything's a little bit more modular. And we have a proper querying of the smart objects, at least until they fix that find smart objects function. Until they fix that, this is probably the way to do it, because this right here is the problem. This find smart objects, even though we're giving it a user actor and we're giving it our request, it seems to be querying this world origin right here and not the actual actor. So I'll look into that. That could be a misunderstanding on my part. I don't see why it should be. If it is a misunderstanding, I think they should make this a little bit more intuitive. So if you pass in a user actor, I think it should be looking for it based off of that user actor and not the world origin. I don't know why that would even be a thing. Why would I ever want it to be looking around the world origin? But anyway, we got that fixed and out of the way. So before we go, I guess I'll go ahead and no. We're going to do this in the next video. So in the next video, we're going to extend this so that they randomly walk around, and then after maybe randomly they'll look for a smart object. We'll do that in the next video, and I'll see you guys later.